my name is Frank Roglan and I will be doing binary search. So the goal of binary search is in a sorted array to find a singular element such as 8 or 1 in this array. And so the steps are that you need to keep splitting the array and asking if it's higher or lower than that value, and then keep getting the array smaller and smaller until you get the value. So there's only one precondition for it, and that's that the array must be sorted, meaning that all the values are chronologically going up. So if we were to sort this array and look for a value, let's say 8, what we do is we'd find the middle point being 4, and what we do is we'd say, is 8 higher or lower than 4? And if not, we'd split all this part of the array, and we'd only use this part of the array. So now what we do is we'd find the middle point, we'd pick either, and we'd say, is 7 higher or lower than 8? And we'd say no, so then we'd find this new array. With this new array, we'd say, is 8 higher or lower than 8? And then we'd find our value being 8. So one takeaway from this as well, though, is that it does not matter if there's not an even midpoint. It does not matter as long as you keep consistent with one being left or right. So if we had our original array, as shown here, if we didn't have the 0, for instance, and we had 7 or 4, it didn't matter if we picked 4 or 7 as our midpoint. We just had to stay consistent that if we cut it in half, that we'd always use the left value, let's say, as our midpoint. Binary search can be most often mistaken with linear search, which in linear search, each element is counted until the specific element searched for is found. But binary search is where you split it and then you search for it through a series of splits.
So the runtime complexity for binary search, as shown here, is that the best is 1 and the average and worst are both log n. So as you can see in the best example, when you're looking for the number 24 in this array, when you split it, you'll figure out that 24 is being the middle of this array is the number we're searching for, meaning that it only took us 1 to get it. For average and worst, as you can see here, if we're looking for the number 44, we'd split the array and start at 13. We'd figure out that it's higher than 13, so we go from between 15 and 44. We'd figure out it's higher than 23, so we'd go between 23 and 44, and we figure out that it's 44 here. And the same thing in the worst case. And the time complexity will always be 1.